Hi, I'm Jay Phelan. Let's learn some biology. If you look around nature, you see some pretty spectacular things. You see red deer, huge racks of antlers, giant, cumbersome, unwieldy. You look at a male peacock and you see these huge fans of tail feathers. It's very difficult for the peacock even just to walk around, to say nothing of finding food, finding somewhere to sleep, and so on. Or the frigate bird. If you ever go to the Galapagos Islands, you probably see some of these. Males have this huge big red pouch, and it's all inflated, makes it hard to walk around, hard to fly, hard to eat, hard to do pretty much anything, but they've all got them. So it makes you wonder. You think, hey, you've got these traits that they don't seem to improve an individual's ability to survive. And in fact, they might make the individual more likely to die. So how can that kind of trait, how can those traits be produced by natural selection? That just seems counterintuitive. Well, if you look closer at the specific cases, for instance, of the examples I gave with the red deer, males, females choose their mates based on how big are the antlers. So the females love a giant rack of antlers, and that's what gets them to pick one male over another. Or with peacocks, females like males that have the biggest fan of tail feathers. In particular, they like the eye spots. And there's something about that that makes the female more likely to choose a particular male over another as a mate. Frigate bird, same thing. How big, how bright red, how uniform is it? Those all influence whether or not a male is likely to get selected. And this goes throughout huge numbers of species. You see these traits that are clearly, obviously impeding survival, and yet there they are. They're produced. So we think of these as costly traits because your probability of surviving goes down, but for whatever reason, it increases your likelihood of obtaining a mate and obtaining mating. So we see things like racks of antlers, brightly colored tail feathers, large body size, and it's not just things like these bright, bushy feathers that are the appealing trait. There can be behaviors as well, a display with them, a courtship dance, an ability to build a fancy nest. Among Western grebes, the male doesn't just come up to a female and say, hey, what do you think? Might you be interested in me? Instead, the female flies across the surface of the water and the male has to follow right behind her. And he has to do it perfectly uniformly. And then she goes straight up. And he has to go straight up. And then she dives down into the water. And just before she hits, she pulls out. He has to follow her. He has to do this, mimicking all of her moves. And this goes on for hours and hours, days and days. For a couple of weeks, she's doing these dances. And he's got to follow her. He's got to show that he's committed. He's able to do it. He has the skill to do this. And this elaborate courtship dance is necessary before a female is ever going to choose a male. You've got these bowerbirds, and the males, they take all these little feathers and sticks and stuff, and they lay them out, they arrange them into a nice little nest, and then they sit there, all proud and wait for females to come. And the females will come and they'll land on a branch nearby and they look at it and they might go down, they might walk around. It's like an open house and they're kind of checking it out and they may like it, in which case they stay and then they will agree to be that bird's mate and maybe produce offspring. Or they leave. They go look for another male and they check out his open house. What does he have going on? And with these bowerbirds, it's sad. Sometimes you'll get a bunch of females will all check out his house and he's made it all nice, and then they leave and you'll see him smash it all down. And then he picks up all the feathers and he tries to build another one. So he has to start over if the other one is not working. You've got bird of paradise males. They've got these really dramatic displays, very brightly colored feathers, the darkest black feathers you're going to see in nature. The females need to see this dance, and they evaluate the male. How good are you? And based on that, they make decisions. You look at these bowerbirds in Indonesia, and they build a huge, massive house saying, check this out. And then they arrange flower petals all around. You look at this, that's pretty impressive. But then you go a few hundred yards away and you find another one. You're like, oh, look at this one. Now you've got more colored flower petals. You've got them organized. You've got them leading into the house. And all of a sudden you look back at the other one and you're like, yeah, that's not that great. And so the females are using choice. And in response, we have these males that have these elaborate behaviors. So you got physical features, you've got behaviors, and the question then, hopefully the answer is clear. How does natural selection cause traits like this that make it hard to get food, hard to avoid predators, hard to sleep, hard to do anything? How does natural selection cause those traits to increase in frequency in the population? Well, it does it because, remember, natural selection is not a magical process. If you have variation for a trait, and it's heritable, and there's differential reproductive success based on that trait, then it's going to increase in frequency. So it's not about how well does the organism survive and get food. Those things are necessary, but you still need to have reproductive success. And maybe that's common throughout the animal kingdom that we see these costly traits. Certainly we wouldn't see these in humans, right? We're not interested in stuff like that. I mean, look at this guy. He's no helmet on. Motorcycles are so dangerous. Smoking, it's dangerous. Clearly, no one's going to be attracted to that, right? We can all agree. No, just kidding. Here's a graph showing some data where they've actually looked at the number of eye spots that a peacock has, and then they see how many mates does that male get, because sometimes multiple females will choose the same mate. So if he's got 140 eye spots, pretty impressive, doesn't get any mates. But if he's got maybe 150, you get a little bit more, 153 or 154, all of a sudden you start to get more. You get up into the 157 or 158. Barely different, a couple percent different. The females notice this, and as you see here, those males get additional mating opportunities. And whatever the genes are that are responsible for producing 160 eye spots in your tail feathers rather than 140, there are more copies of those next generation. So plain and simple, natural selection is responsible for these traits. And this version, it's still natural selection, but we call it sexual selection when you have natural selection, variation for a trait, it's heritable, differential reproductive success, but the differential reproductive success is decided by one sex on the other. And then it also can lead to sexual dimorphism because you're essentially running a directional selection experiment on one sex within the species. So here's an example, and it's just natural selection, but we call it sexual selection because one sex is providing a strong selective force on the other. In elephant seals, the males fight for control of the beach, and the females choose as a mate the male who controls the beach. So the biggest male, the best fighting male, is typically the one that is going to control the beach or most of the beach. And because of that, those males get more mating opportunities. So over time, what's going on? Well, the males that are the biggest are more likely to leave lots of copies of their alleles for bigness. The males that are good fighters, the males that are able to control the beach. And so over time, this is what happens, sexual selection. And it can lead to sexual dimorphism because the females aren't having any differential reproductive success based on their body size. So check out this, just the difference in skull size between the males and females in the northern elephant seals. Because the females have been doing directional selection on males for hundreds, thousands of generations, males have responded. And now you get this tremendous sexual dimorphism in this species. So that's how it goes. Sexual selection is just natural selection, but one sex is deciding on which traits are being selected for in the other sex. And because of this, sometimes you end up with sexual dimorphism. Sometimes you end up with traits that are costly, that they harm survivorship, but they are beneficial when it comes to actual mate selection and reproductive success. And that's more important.